All right, these are your video lesson notes for slides 7 through 13, 2.2.
Okay, so we are going to start with chemical bonding. So that's really the big focus of our second unit. So we've kind of recapped some of the information from our first unit by looking back at atomic structure and electrons and their importance. And now we're going to see how those valence electrons interact in a way to result in chemical bonds, more commonly referred to as chemical reactions. So one of the ways in which chemical reactions are different than stuff we've talked about previously is that they make compounds. And compounds consist of two or more elements chemically combined. And what's cool about compounds is that they tend to have different properties than the elements that make them up. So for example, we have NaCl, all right, Na is sodium and Cl is chlorine. But together, when they chemically combined, they make sodium chloride, AKA table salt. So I'm sure you can picture table salt, right? Or a salt shaker filled with salt, and think about some of the characteristics that you would list if you had to describe salt to someone. You might say its color, it's white. You might say its size is tiny. You might say its texture is kind of grainy or rough. You might say its taste is salty. So those are some characteristics of salt. But if we were to look individually at sodium by itself and chlorine by itself as elements, you would get a really different, a totally different picture, all right? Sodium is a highly reactive alkali metal, meaning it takes very little to make it want to boom, explode and react with something else, okay? Chlorine, on the other hand, is a highly reactive, greenish, yellowish gas. Wouldn't want to eat either of those. You would be dead. And again, those colors, those textures, those obvious tastes, none of those things are going to be the same as we would have for sodium chloride. So when we have these bonds that occur, when we have these chemical reactions, we are going to end up with totally different properties. And that's one of the really cool things about chemistry. So why is it that sodium, this highly reactive white, toxic metal, and this poisonous yellow greenish highly reactive gas, why do these two things want to form a bond? Just like we said in Unit 1, they want to become happy, right? They want to have electron stability. They want to look like a noble gas, right? They want to have that magic number of valence electrons to be able to be stable. And the way they do that is by exchanging valence electrons, and that results in that happiness. And there are two ways in which they do that. They do that by either forming what's called an ionic bond, or they form what's called a covalent bond. And Ms. Case is going to talk you through both of those.
All right, so bonds are formed by a transfer of electrons. Somebody loses electrons and somebody gains electrons. And for example, we're going to go back to that example of sodium chloride there. Neutral sodium has one valence electron. So that means it needs to lose that one electron in order to become happy. Therefore, making our sodium a 1+ ion there, which will make it a cation. Again, remember, positive charges make it a cation. That T for cat is a good useful tip for you. So that means that our neutral chlorine has 7 valence electrons, so it will need to gain only one more electron for it to become happy, thus becoming a chlorine with a 1 negative charge or a 1 charge, making it an anion.
And you can see Ms. Case's favorite dot diagrams down there in the bottom corner. You can see the valence numbers for sodium and chlorine. And again, that relationship between taking one electron from sodium, it's got one to give. Chlorine has one open spot there at the bottom, looking for one electron. So it's like a match made, in the movies, where that one electron is going to be moved, stolen, taken, given to chlorine, and then both of those elements will now have full valence shells. And that's what we see in an ionic bond. So ionic transfer, notice that color coding, that underlining. Key word for ionic is we transfer electrons. It is given away and it is taken.
All right, so how can you predict how an ionic bond will form? Okay, opposite charges will attract to each other. So again, that sodium was a positive charge and that chlorine was a negative charge. So those are opposite charges which will attract, forming that ionic bond. Overall, we want our charge of the ionic compound to equal 0. That is our magic number there. We want it to equal 0. So a 1 plus a 1 minus will equal out to 0. Ionic bonds form between metals and nonmetals.
So I'm going to jump back here to the previous slide really quick. So what happens when we transfer this electron here to chlorine is what we've created are two ions. We've created a positive, a cation in sodium, and created a negative anion in chlorine. But we don't have a bond yet. All we've done by transferring the electrons is create ions. We create charged atoms. And so when you have things that are charged, like different sides of a magnet, what is going to happen is if you have two opposite charges, a positive and a negative, they are going to be attracted to each other. You know, Google, or here in your head, Paula Abdul, all right? Opposites are going to attract. And so what that results in then is what we refer to as an ionic bond or an ionic compound. There is the bond, right? We've given away the electron, we've become ions, and now we are attracted to each other because of this positive and negative charge. Another rule of thumb, as Ms. Case pointed out, and it's color-coded for you to highlight, is that charges for a whole compound have to equal 0. So sodium chloride as a compound must have an overall charge of 0. So that means that whatever the cation charge is has to cancel out whatever the anion charge is. And that's where you see that math down there of the +1 and the -1. Notice that sodium is found on the left side of the staircase. So typically when you form an ionic bond, you're going to have a metal, something from the left side. And then you'll notice chlorine on your periodic table is to the right of the staircase. And so typically the second element in an ionic bond is going to be a nonmetal, something found on the right side of the periodic table.
All right, polyatomic ions. These can be found on the back of your periodic table or that second page. It is an ion that has 2 or more atoms covalently bonded together, and their names tend to end with an ATE or an ITE. So as you notice when we were talking about sodium chloride, okay, normally they'll end in an IDE, and when we're looking at polyatomic ions, they are ending in an ATE or an ITE.
And these are some of the common polyatomic, poly, like from math, all right, a polygon, right? So poly meaning many, atomic referring to the atom. So many atomed ions, that's what a polyatomic ion is. It's a many atomed ion. So that group, so let's just grab one here. We'll just do carbonate because it's at the top, CO3. And that whole entity, that whole group, that one carbon and those 3 oxygens that are stuck together in a bond, together they have a charge of -2. And that's why we refer to it as a polyatomic ion. There are technically 4 atoms in here, 3 oxygens and 1 carbon. And that whole entity, that whole polyatomic ion has a charge of -2. And so in addition to metals and nonmetals forming ionic bonds, you might have polyatomic ions forming bonds with some metals or nonmetals depending on the charge of the polyatomic ion.
All right, covalent bonds, when we think of covalent, we think of cooperating. They're formed by sharing of electrons. They can occur between 2 different atoms or 2 of the same atom. And we're going to take a look at the diatomic molecules shortly. They form between nonmetals. Okay, so these are nonmetals that are sharing their electrons.
So as opposed to ionic is I have an electron or electrons I want to give away, or I have a need, I need to gain electrons. And so we're literally going to move that electron from one atom to another. In a covalent bond, as you can see here for water, so H2O is water, all right? In a covalent bond, what you end up having is a sharing. So instead of a giving away or a taking and the creation of ions, we don't do that here. We don't create any ions in a covalent bond. all we do is say, you know what? I'm going to let you borrow my 1 electron oxygen for a little while and it can go here, but then it's also going to hang out by me for a little bit too. But then it can go back and it can hang out by you, but then it's got to come back and hang out by me. Okay. So in a covalent bond, electrons are shared and shared between the atoms that are involved in the covalent bond. And that could be between atoms of different elements. So here we have 2 hydrogens and an oxygen, and they're all sharing some electrons. Or you could have 2 of the same. In this case, we have 2 oxygen molecules, and they are sharing some electrons to make both or all of the elements that are in the covalent bond, make them feel like their valence shell is full. Even though if we were to count up all the electrons, we would technically be short, right? We'd be missing electrons because we haven't gained any or lost any. We've just taken what we had and we're just switching it between 2, 3, 4 different atoms so that those electrons are spending time around each of them, making them feel like they are happy and making them feel like they are stable. And again, these are forming between non-metals. So that means we're going to be primarily looking at elements that are both to the right of the staircase. Your one exception to that, remember, is hydrogen. It's on the wrong side of the staircase. It is a gas, it is a non-metal, but it is on the left side.
All right, diatomic molecules are another way covalent molecules or covalent bonds are formed. And these diatomic molecules here are just a few of the examples that you'll probably be seeing. All right, ionic versus covalent. So this is a great slide to probably highlight and put a box around, as it's kind of like a summary slide about the difference between the two, ionic and covalent. Ionic bonds transfer electrons. They are opposite charges that attract to one another. They consist of cations, right? Those metals or polyatomic ions that are the positive charge. And we have the anions, which are those non-metals or polyatomic ions that have a negative charge. And then we have our covalent. Covalent is sharing of electrons. They can be equal or unequal sharing, and they consist of 2 non-metals. And always remember, just like Ms. Laporte said, that hydrogen is a non-metal, even though it is on the wrong side.
Note your keyword differences here. Ionic, transfer. We gain, we lose. All right. Covalent, we share. Everybody gets to use the electrons. All right. Sometimes that sharing is equal. The electrons spend time around each of the atoms equally. Sometimes it's not an equal sharing, like maybe when you share stuff with your siblings. All right. It might not exactly be an equal sharing, but either way, it's still a covalent bond. We're still only sharing the electrons. No charges are generated. No ions are present in a covalent bond. No metals are present in a covalent bond. All of those attributes, charges, transfer, metals, those are all going to be present only when you are working with ionic